Hello, everyone. Right now, beneath our feet, an entire system is handling everything we flush away and making our life so much easier. In every wastewater treatment facility, hundreds of pumps are fighting gravity. They're pumping millions of liters, consuming tons of energy every second. And the thing is that they don't know what's coming next. Our mission at lpump is simple. We are trying to make these pumps, which are blind and energy hungry, into systems that are intelligent and self-optimizing. I want you to meet my friend. He's Jamie. He manages a wastewater treatment facility, and to keep everything running smoothly, he hires a team to keep an eye on it every second of the day. And what they have to do is juggle weather forecasts, trying to predict electricity demand and how that impacts their work, and then control optimized inflow rates in their system. And controlling all of these variables, especially since just last month, all of Europe moved to 15-minute electricity pricing, the job has come more and more difficult. And at this point, Jamie is a human, and juggling all these variables, it's very difficult, and surprises can happen. And the thing is that when these surprises happen, the cost can be astronomical. See, a single pumping station for wastewater can consume the energy equivalent to over 500 households. And when these systems are running unoptimized, they can incur unnecessary losses of over $100,000. And when Jamie sees these sorts of numbers in his electricity bill, it's safe to say that Jamie is not very happy. Well, we didn't want to just feel bad for Jamie. We rolled up our sleeves and tried to figure this out. We went to find every piece of academia, all the data that we could find, different papers on past optimization methods to understand how the process is working right now in this industry. We have developed a solution that combines mathematical optimization methods with intelligent reasoning models, and through this, we have also formulated this in a paper for all of you to see. But even though I love this as a nerd, all this beautiful logic, it doesn't provide much value without usability. That's where a user interface comes in, and I'd be happy to show it to you next. From lpUmp's user interface, wastewater facility operator can simulate how different impacts in electricity prices, weather forecasts, for example, rainfalls, impact their system, and what is an optimized way to operate the wastewater facility. Here we see the absolute optimized way of operating different pumps, how many pumps should be operating, and then what you are saving, essentially, financially in the end. And then AI explains why this decision is best to you. Through user feedback and really hearing, trying to understand the end user's case here, we tried to understand what's important, and this is what we have made. And what this means is that you're moving from juggling thousands of variables manually in real time into a system which is intelligent, optimizes itself, all from a single view. You see beautiful analytics which tell you everything you need. And it's safe to say that at this point, Jamie is a lot happier. But the thing is that Jamie is not alone. This is a problem that every city in the world faces. We have learned that this is a truly global challenge, and optimizing these systems is no longer optional. It is really becoming a necessity. Valmet is already at the forefront of industrial automation, and with partners like them, lpump can be scaled to a solution that is ready to be taken across the globe. First, in facilities like the Blominmäki facility of HSY in Espoo, to pumping stations all over Finland and across Europe and beyond. Throughout this weekend, we started looking at a messy system which has a lot of data and difficult to interpret, but we've learned that now lpump can really help the operator to run things more smoothly, cheaper, and with a lot less stress. Thank you so much for your time.
Hey, is this on? Yes. Thank you so much for the demo. Curious to hear, like, since there is a team of 4 and only one, like, telling the story. So could you share a bit, like, what each and one of you like worked on during this week, and how did you divide the responsibilities?
Sure. Actually, we have 5 people. One of them is in English exam. So yeah, we have 5. Emil here. Emil is the pitcher guy, as you can see. Then me and Elias, we study mathematics and system sciences. So it's basically solving exactly problems like this. And then we have Pyry. Pyry is the data scientist guy. And then we have Robin, who's also doing software development. So basically, the split was us mostly doing the technical stuff, me and Elias working on the model, and then Emil on the business side.
Talk about the mobile desktop app. Did you wrote a paper and you did this all in the weekend?
Yes.
Okay, talk about the stack, like mobile desktop. What'd you guys build? You're showing a picture of a phone behind you. Just curious, like, what did you guys build the front end in?
We use just Next.js, so
Web, okay.
Yeah, I think we're carrying on the same topic. So talk about a little bit about the tech, right? We did a pitch. Tell us about what you were doing, technology, what models, how you did that part of your application.
right. So I think Otto is the best one to explain the optimization algorithm we use.
Yeah, so the algorithm that we use is called MILP, or so it's mixed integer linear programming. So it's a method that combines integer programming and linear programming to find optimal solutions to problems exactly like this. And then we also have the AI part. So we first do the hard things, the optimization using the algorithm, and then we use AI to reason that why we did this, and then we explain it to the user.
Real quick, why pumps? Why did you guys choose pumps to work on? Was that a challenge? I'm just curious.
Yeah, so Valmet came up with this challenge. It's a real problem. We have also been working on these kind of problems, for example, last year in Junction as well, like a hard technical problem. So we have good experiences in like picking the hardest problem, and it's also mathematical, which we all like. So that's what we ended up doing.
All right, thank you so much, Lambda Pump. Please give them a hand.